All right, number 3. The proportion of brown M&Ms in a milk chocolate packet is approximately 14%. Suppose a package contains 52 M&Ms. State the random variable. All right, again, this is a little bit ambiguous. Let's assume we're talking about how many brown M&Ms there are. So we'll say x equals the number of brown M&Ms. Argue that this is a binomial experiment. Okay, so in order to be the binomial, again, it has to fit the 4 characteristics. You have to talk about whether it's independent, whether the probability of each M&M being brown is fixed, so p is equal to 0.14. You're counting up the number of browns out of the bag, out of 15, and the number of trials is fixed. Oh, it's not 15, right? It's 52. And the number of trials can't change. And in this case, it's 52. And so it's a pretty safe assumption that this is, in fact, a binomial. C, find the probability that exactly 6 are brown. So we're going to do probability x equals 6. So again, we'll just use the calculator. I'll show you the formula. So it's going to be the combination of 52 things taken 6 at a time times 0.14 raised to the 6 times 0.86 raised to the 40, what would that be, 46th? So we could type that in, but we'll just do the binomial. So we'll go distribution, binomial PDF. Oh, Poisson, there it is, binomial PDF. And there's 52 trials. The probability was 0.14. The x value was 6. And we get, oh, I typed it into the wrong spot. Let's try that again. So binomial, there were 52 trials. The probability was 0.14. And we wanted 6 successes. And I get 0.3949. So this is going to be 0.3949. That seems awfully high. Oh, yes, look at what I did. It's like, that seems pretty darn high. I did binomial CDF. So let's go back and let's fix that. It's binomial PDF. And there's 52, 14, and 6. And that value is 0.148. There we go. Okay. D, 25 M&Ms are brown. Same thing, but now we're just going to change this to 25. And that's 3.66 times 10 to the negative ninth. So E, C, D. So probability that x equals 25. So that's a combination of 52 things taken 25 at a time times 0.14 raised to the 25th times 0.86 raised to the 52 minus 25. What is that, 27? And that turns out to be 0.0, well, we're not going to write all this out, 3.66 times 10 to the negative ninth. Amazingly unlikely. F, would it be unusual for a package to have only brown M&Ms? If this were to happen, what would you think is the reason? Okay, well, yes, obviously it would be shockingly unlikely, right? So E, that'd be 0.14 raised to the 52nd, and this is going to be approximately 0. And so therefore, what would you think had happened? I think the machine broke.